graduated from Duke and live in a real life somewhere. I don't know where she is. So now we've got Katie's Lapola's memo page. If you look under topics, hers is there. So anyway, I just won't tell Rachel that I've replaced her. Okay, so there are a lot of times in the English language we tend to use these two words incorrectly and almost interchangeably, like a series of numbers or a sequence of numbers. Okay. Anytime you start writing a list of numbers, you've got a sequence. Okay. So a sequence is a list of numbers. And so this, okay, is not a series. But can't you see how somebody might misuse that word and say that it's a series of numbers? It's not a series. A series in mathematics is a sum of those numbers, a sum of the list. So if I say series, it would be 1 plus 2 plus 3 plus 4, ... Okay? And so the answer to a series is an actual number. Now, the one I chose to write on the board here is an infinite series. And then there's also finite series. Okay? There's an infinite sequence and a finite sequence. I don't think I need to explain that to you. Okay? Now, can you find the sum of an infinite sequence? In other words, can you find the series of an infinite sequence?
Yeah.
Could we find the sum of this one? What would it have to do to? Yes. And so you're both right. Yeah, if it's getting bigger and bigger and bigger, you're not going to be able to add it together. We'll study this later. If it's getting smaller and smaller and smaller, what's really odd is you can actually find the sum. I'll prove that to you later. But let me just tell you that when you're in pre-cal at this point, we talked about it a little bit, and then in calculus, so many people think, oh gosh, you're such a math nerd because you've made it all the way to calculus. And it's funny that we're really not super nerdy at that point because we're grappling with things that are really, really weird, like imaginary numbers that are in our world, and we've got to deal with it. Or like we talked about sound waves, that hundreds of years ago someone had said, there's this wave going through the air and it's invisible and you can't see it, but one day we'll have be able to talk to people in another country in real time. You'd have gone, go away, let's lock you up. You deal in mathematically with some really weird stuff, whether it's biological or mechanical or electrical. There's so many things in calculus. We actually quite often add up an infinite amount of numbers in a finite space. And it's almost like your magic. It's sort of like Harry Potter, Chronicles of Narnia, or whichever one you like the best. I like Chronicles of Narnia. Harry Potter. Y'all probably like Harry Potter. Yeah, it kind of got overtaken with the. They're similar to me.
I actually watched that and read that more than Harry Potter.
Really? Yeah, I love them.
I've always wanted to try like a candy thing. Whatever it is.
Oh yeah, I know. Yeah. I've forgotten about that. But anyway, we've got to grapple with a lot of things that we don't really understand or that seem illogical to become logical. And so, Bella, say again what you said when I said, can we find the sum of infinite series? You said it's got to be...
No, because there's no stopping.
Okay, but what's going to happen if it's getting smaller and smaller and smaller and smaller? I couldn't double 200 all of a sudden. And smaller and smaller. What is that getting closer and closer and closer to? Zero. Okay, so I'll use this illustration again probably. Suppose that instead of a running program, of running more, maybe I think, oh, I'm running too much, I'll start to run less because people are like, fussing at me and I need to run less for whatever reason. Okay? I tell you what, I'll use that example real quickly, then we'll go to another one I just thought of with basketball. If say today I was going to run 4 miles, okay? And then next week, I'm in trouble with somebody and I've got to run half as much as I ran the week before because they're worried about my run. So I'll run 2 miles. Then the next week I'll run 1 mile. Then the next week I'll run, how far? Half a mile. Then the next week I'll run a quarter of a mile. Then the next week I'll run. Pretty soon I'm going to be sitting on my couch with the remote and go, it's time for me to run. Done, right? And then what am I going to be doing the next week? I'm going to go, here's my remote. Yeah, eventually I'm not going to be doing anything. Do y'all see what I mean? So it's that weird concept that Ella's brought up of there's still a mathematical number, but also Rebecca's noticed that it's getting closer and closer and closer to 0, and there's actually a thing called a limit that lets us handle that, okay? Another example is bouncing a basketball. Suppose I had a basketball and I bounced it and we recorded it with some sort of device, which you can do actually. You can even hook up your calculator to some things called CDRs and CDLs. But you could bounce it and record the distances and say it went back up 3/4 of the distance every time. Girls, you and I could watch that until the basketball was what? Not bouncing, right? Because the last one would have and then eventually it's going to stop. But you should always be able to take 1/4 of a 1/4 of a 1/4 or 3/4 of a 3/4 of something. So it's going to be an interesting thing we talk about later. I just want to kind of set the stage, okay? All right, so many sequences. A sequence is just a list. It's separated by commas, okay? It does not have to have a pattern. It does not have to have a pattern. But our job in honors pre-cal, and then if you take BC, or again, a lot of you will be in Cal 2 one way or another, it's really important that sometimes if we can labor away and notice the pattern, okay? Some things don't have a pattern. If you notice a pattern, we want to mathematically describe that so that we can move on, whether we're describing something or writing code or whatever it is, okay? So you'll see this again also. But if it doesn't have a pattern, that's okay. We'll talk about that. If it does have a pattern, we'll talk about that. I'll give you some really good windows into how to write an equation for the series, okay? I'm sorry, I just misused the word. You should have gotten me, okay, for the sequence. Sequence is a list of numbers. All right, so we're in chapter 8 now, just because what's happened now that we're through with trig. We'll keep having memo quizzes on your memo page. Won't probably be, I can't think of something we would add to it. If you want to start if you kind of like that idea for a unit, you could start your own blank paper for sequences and series, and you'd have one place that you write everything that's important about formulas there. And so it's a good study tool to know for the future. Let me see what I was going to say. Sequence of numbers list. So, I know what I needed to say. We have to have a way to talk about the terms, like this. Okay? What I'm trying to tell you, you know how math is a language. So I'm able to walk up to you right now or write that. You'll be able to pick this up pretty soon. That means the 4th term is 4. Okay, so this is something I'm speaking to you. I have to use a subscript so you know I'm not talking about a number. And get used to it in pre-cal and calculus. A, C, A's and C's and K's, things like that. You're already used to K and N. Those are usually numbers, okay? So this is A sub n means any term. And I can say the specific term, what does that mean? A sub 5? It means I need the 5th term, which we don't see right now, but we could suppose it's 5, don't we? Which is another thing. You can't assume a pattern too much unless you know more about the sequence, but I'll get into that later. All right, so you might see A sub k or A sub n to talk about any general term, and then I can say the specific term. So by the time you get to test day, if you see this, I'm trying to tell you I need the 20th term, okay? So, of course, I'm going to teach you a way to even do that. And, every few years I have some poor child that writes out 200 terms and circles it and goes, here it is. But there's going to be a better way, okay? I'm being a little bit facetious. I've seen somebody do this one. But obviously there's going to be a better way. You won't do that. I'm not worried about you. All right, so you're going to have some homework that looks like this. And I want you to be able to read the lingo, the language. Okay? So this says, and in your homework it'll say list the first 4 or first 5 terms. So I want A sub 1, A sub 2, A sub 3, A sub 4. And so what this means is what number term are you on? Do you see those are the same thing? Okay? If I use this, that means I'm talking about the term. If I use this, I'm talking about the number of the term. All right? So I'll reiterate that in a minute. So I'm going to go 3 times 1 minus 2 is 1. 3 times 2 minus 2 is 4, sorry. 3 times 3 minus 2 is 7. 3 times 4 minus 2 is what? 10. 12 minus 2 is 10. All right, so if I say A sub 3, do you see that would be the 7th term? I'm sorry, the 3rd term would be 7. Okay? All right, another one. Try this one. I'll just be quiet for a minute. Here's your formula. 3 plus negative 1 to the n power. You're actually learning more than you know right now by looking at these 2 examples. So try that on a piece of scratch paper or in your head if you don't have something to write with. Did you get it? Okay. Wait just a second more before Bella gives us the answers. All right, Bella, what'd you get?
For A sub 1, I got 2. A sub 2, I got 4. A sub 3, I got 2. A sub 4, I got 4.
Cute little sequence, isn't it? So now you already see that what if I asked you A sub 20 or A sub 200, okay? What would you do in this case? I hope you wouldn't write out all 20 and go, here it is, all right? What would you do in this case? You could find any term. Do you see why I call that any term A sub n? Hopefully, would you say 3 times 20 minus 2? You know right what it is. Here, Bella's established a pattern. I hope you all got this. 2, 4, 2, 4, okay? And so you can figure out what's happening with your evens. It looks like to me A sub 20 would have to be 4, okay? One thing I want you to super duper notice here. All the rest of the year, well, we won't be on secrets the rest of the year, the rest of your life. If you want something to alternate in AP Cal BC, and later in a week or 2 in here, you can use negative 1 to a power. It forced it to alternate. Okay? So just remember that. It may not always alternate 2, 4, 2, 4. It's because we added. It made you add 1, subtract 1, add 1, subtract 1. If I multiplied it, it would make it alternate positive, negative, positive, negative. You would have negative 1 to an odd power, which is negative. And what would negative 1 to the even powers be? Positive. So there's a way to make that happen that I wanted to go ahead and point out. All right, so let's look at this one. I feel like there was another thing I wanted to say about that, but I don't know what it is. All right, A sub n is equal to negative 1 to the n power over 2n minus 1. I wrote it down wrong. Don't do it yet. All right, so you're going to find A sub 1, 2, 3, 4, and we'll stop there. Your homework asks you, I think, to find the first 5. So your first few homework problems are just filling in, but still I think you should do it instead of sit there and stare into space. And it's good for you to have the feeling of doing it. Everywhere there's an N, what are you going to put in? The 1, the 2, the 3, the 4. Raise your hand when you think you have it. Got it. Anybody else? I have 2 people that got it. Okay, Grace. All right. All right, does anybody want to volunteer to give their answer? All right, Bella, you want to go again?
So -1, 1/3, -1/5, 1/7.
All right, Lily, Rebecca, Grace, y'all had the same thing? Okay, because I saw those hands go up. Some of you, I hope, were on your way to that. Does anybody need some explanation there? Everybody okay? Isabella?
0 or 1 for the
Okay, thank you. That's what I was going to say up there. Thank you so much. Remember when I said there was something else I was going to say and it flew out of my head? Girls, listen to her great question. I wonder what experiences made you ask that. I'll find out. You could be asked for a sub 0. And I'm not sure that's even what you were asking me. But when I say find the first 4 terms, she asked me, do I start at 1 or 0? What she's talking about is this. You see it on SAT problems sometime, and you definitely see it in physics. You're going to see it in math. If there was an ACT question a while back that asked on a street that started with like an address of 501, 502, 503, 504, 505, they didn't draw it out. I'm sorry, that's just the SAT workshop tutor person in me. I would immediately start drawing it out. They listed you were going from 501 to 505. In fact, it was a whole lot more though. They weren't just going from 501 to 505. I just wanted to do that to explain it. It was a whole street, and they're like, how many mailboxes do you need? And some people would say 4. Do y'all see what I mean? But how many mailboxes do you need? Okay, because that's your initial 1. Isn't this a sub 1 if I'm going down the number line? That's the second one, that's the third one, but do you see you need the initial one? Y'all see it in physics with initial velocity, I think, V sub 0, okay? T sub 0, like the initial time. It means we haven't started counting yet, and once the clock starts, 1, 2, 3, things start to change, and so sometimes this initial amount is very important. But if I say find the first 5 terms, you would start with 1, okay? There'll be, thank you so much. It can get confusing, and I'll make it less confusing. But if I say find the first 5 terms, start at 1. And that's universal. That's not unusual. But you'll see, now you should wonder when in the world am I going to do the other thing. Okay, now what we're going to do, if I can get this to change slides, is we're going to learn how to write formulas, okay? I think I'll start with these. Okay? We'll come back to this slide, though. Watch this. I'm trying to think. I'm actually going to skip the next example in the book because it's kind of misleading. So I'm going to move on to this. Let's say if I have 5 times 2 is 10 times 2 is 20. I'm sorry. I was doing something different. Now that I've accidentally done that, let me write these 2 words down. For the next few days, we're going to be studying arithmetic and geometric sequences. Okay? But you know how there's even functions and odd functions and neither functions? By far, probably the most likely is you have neither, if you remember that from your Algebra 2. But if I have an even function, my life's a lot easier because I know it looks the same on the either side of the y-axis. Okay? You'll run into that a lot, actually, in calculus. I think when I learned this, my teacher spent so much time, and I will also in arithmetic and geometric, I think I thought that's all there was. There's Fibonacci sequences that are not arithmetic or geometric. You've heard of them. There's that cute sequence that Bella quoted to us, 2, 4, 2, 4. That's really cute, but it's not arithmetic or geometric, but I like it better than either one. So please don't get stuck on arithmetic and geometric. It's just that they're so common in the real world that we do have to grapple with them, okay? So I wanted to write that up there because my teacher wrote arithmetic and geometric. But there's also a huge category of interesting. Some of them don't even have a pattern. Can't you imagine just a sequence of numbers coming at you? And there's like code breakers that are hired for that. You know, the CIA people, what's the sequence doing? You can't figure out the pattern. What are you going to say? Thank you. Yes, and if you could find a pattern for that, that'd be great. But that would be a great sequence of numbers. You're right. Arithmetic is when you're adding the same number every time. Geometric is you're multiplying. Have y'all heard these in Algebra 2? I can't remember. Is this okay? Bella's heard it. She's coming from a different school. Have y'all heard these? Okay. Okay. All right. I'm going to pretend like you hadn't heard it, so please let me know if it gets too simple, and I can speed it up, except for Bella's heard it before. Okay, we're going to learn a lot about these, or some of you have done it to study for standardized testing with your tutor or whatever it is that you're doing. But there's arithmetic and there's geometric, and then there's neither, which is very likely. All right, let's go back to this. I've erased them. I don't know if you remember what used to be up there. Sorry, it's not where I want to be. I want to be right here. Where did I put it? Where did I put that 10? Oh, I started writing it wrong. That's why. Okay. A second ago, I was going 5 times 2 is 10 times 2 is 20. That was geometric. We're not going that route right now. Well, let's keep on. I've started that. Okay? You don't have to know these words yet. Okay? So I'm just talking about a sequence of numbers. Okay? So we have 5 numbers. Now I want to write a general term for these numbers, and calculus many times will go dot, 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 and write what our sequence is doing right there to let you know you can find any one that you want to. Now your job would be to come up with a formula to where your friend could find a sub 200, okay? And so now we're coming up with the formulas ourselves. All right, Bella? Almost. Let's start there. Let me show you how she knew that, okay? In fact, it's not quite. It's going to be this one. 5 plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13. This one, ironically, is going to be over here. Now, what do I mean by ironically? What am I doing on this one? I'm adding by 2. So aren't you a little surprised I multiplied by 2? Okay. And what are we doing here? We're multiplying by 2. But if you multiply by 2, and then you multiply by 2 again, and you multiply by 2 again, you get an exponent, okay? So if I'm multiplying, it's going to be 2 to the n power. If I'm adding, it's going to be 2 times n always, okay? So if you're adding by 2, you actually multiply by that number in front of n. All right, let's write this one. I've decided that I'm adding by 2. Now I'm going to just try it. You actually have to fiddle around with these, which is really great mathematically, okay? A sub n, what if I did a sub 1? A sub 1 would be 2, a sub 2 would be 4, A sub 3 would be 6. Be real comfortable fiddling around with it, okay? How can you turn 2 into 5, 4 into 7, and 6 into 9? Add 3. Let's see if this is going to work. A sub 1 is 2 times 1 plus 3. A sub 2 is 2 times 2 plus 3. Is it working? All right, so you've got to figure it out with some prior knowledge that I'm giving you. If you're adding by something, if you're adding by 3s, use 3 times n. If you're adding by 5s, use 5 times n. Okay? Bella?
Why can't you just say where a sub 1 equals 5? Or is that just like too much of a cop-out?
It is. You're going to have to be able to do this and write a term for that anybody can pick up and use. I see what you're saying, but you've got to be able to write the formula. We're going to do something similar to that soon, Bella, in recursive that's a bit like what you're saying, okay? Right now, girls, we're doing what are called explicit, and implicit. And in calculus, you'll study explicit equation and implicit equations. You already have actually in algebra. Explicit a lot of times to me means like it's like triple x-rated or something, but that's not what I mean by that. Explicit means it's super clear where you are. It's not implied, okay? It would be like if I said, well, it sure is bright in here. I've implied that I want somebody to turn off the light. I don't want you to, by the way. But if I said, Michaela, turn off the light, then I'm not implied it. I've been very explicit in what I want to happen. Do you see the difference? So we're writing explicit equations right now. Later on, we'll do where it's implied, which is called recursive. All right, let's do this one, and then we're going to crank out some more. Uh-huh.
If the term, if like it doesn't say that 5 is your first term, do you just like assume that the first like the numbers given are like starting from 1?
Yeah, that's what Isabella was asking me. So this is a sub 1, a sub 2, a sub 3. Great questions. You're going to run into some things that if we're told different, we might have to write it a little differently. But right now you're assuming first term, second term, third term, okay? Which can be confusing when all of a sudden you see something starting at 0. We'll talk about all that, okay? Here's the good news. When you're writing your formula, you kind of have a lot of control. So if you wanted to state something differently, if you want to label it a sub 0 to a sub 4, then that would make me write another formula. It's understood that you're starting at 1 unless you're told otherwise. I guess that's what I'm trying to say to Isabella and Isabel's question. Unless it's stated otherwise, you have a sub 1, a sub 2, okay? All right, now if I'm multiplying by 2, like some of you noticed, if you say 5 times 2, and then 5 times 2 times 2, and 5 times 2 times another 2, do you see you have a power? Okay? And here, I was going 5 plus 2, 5 plus another 2. Do you see I have 2 2s? That's why I multiplied, in case you wondered why. Okay, so now I'm going to write a formula. I'm going to go a sub n. I'm going to go, you know what? I'm multiplying by 2. So I'm going to have 2 times 2 times 2 times 2. But I have to make it, watch this. This really plays into their question. I have to make it multiples of 5. Do y'all see that? So then next to that, I'm going to throw in a 5. And this is where Isabella and Isabel's question really comes into play, okay? By the way, I feel like right now my whole class is in some form of Isabella by the interaction of the people in the room. All right, so anyway, if I go 5 times 2 times to the first power, I get 10. If I go 5 times 2 to the second power, I get 20, so I just make it what?
5 times 2 to the nth power minus 1.
Yeah, you can back your power up like this, okay? So now, if Rebecca goes a sub 1, she'll start with 5 times 2 to the 0. What's 2 to the 0? 1. So it'll work, but she saw she needed to slide it back. You can slide things back and forth with a minus 1 or a plus 1. You'll see as time goes by. There was something I was going to say there. Okay, so there's those two. Now let's go up here. And let's write let's rewrite these. I've erased them. Hopefully you kind of don't remember them. What am I doing here? Adding by 3, so you are going to have a 3n, and then you have to engineer it to start at 1. So write a few. 3 times 1 is 3. 3 times 2 is 6. 3 times 4 is 12. Sorry, I got off. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. How am I going to get to these numbers? Minus 2, and there's your formula. And I think that's what I had on the board before I erased it. Okay? Now, this one's really weird. These are a little bit harder to write, but you see it's alternating? It's alternating, so I'm going to need a -1 to the n power. Let's go back to what all of you were asking and that Rebecca stated. I got to make sure my power is correct, and I can change my power easily with a +1 or a -1. Sometimes it doesn't matter. Girls, y'all listen, this is real important, okay? Now, if you don't see any negatives, that means you are not multiplying. If you were multiplying, when you have a -1 to the third, a -1 to the fourth, your signs would be changing. You're not multiplying, you're adding, okay? And this one would be a little bit difficult to write, but would that work? I want to say 3 minus 1, 3 plus 1. I don't remember what I had written up there before. That may be it. 3 minus 1, 3 plus 1, 3 minus 1, 3 plus 1. If your signs are changing back and forth, you'd be multiplying. Now, if I wanted this to start with a 4, I could make this n plus 1. And that my first term would be -1 squared. You can shift your signs back and forth with the n plus 1 or n minus 1. All right, this one's super tricky. How would I expect you to do this? This is -1 over 1. This is 1 over 3. This is -1 over 5. And this is 1 over 7. So I think the top is a 1. Okay? I got that part. What's the bottom doing? Going by what? 2's. And adding by 2, so I have a 2n. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. What do I need to do to get -1? And now do you see how the signs are alternating? That means I'm going to multiply. So I'm going to multiply by -1 to the n. And if it doesn't alternate the way I want to, then I'll make it -1 to the n plus 1 or n minus 1. Either one would work. All right, let's fill in 1. If I fill in 1, will I start with a -1?
Yes.
I will. If I wanted to start with a positive, I would make that n plus 1 or n minus 1. Either one's okay. By the way, not anything to the 0 power is 1. Okay? This is undefined. You're not going to run into it right now, but you've run into it a little bit already. It's a lot like this. Okay? Where you say 0 divided by anything is 0, that's not really true. Okay? This one's undefined, as is this one. There are 7 indeterminate forms that you study in calculus that take you into la-la land. It's like the Twilight Zone, okay? Where you're adding up a finite amount of things and an infinite amount of numbers, and you're getting an answer, all right? Which we'll do. But anyway, those are 2 of the 7 indeterminate forms. Here's another one that you study in Cal 2, which again we get into in BC. And so you're really delving into some weird stuff, which is fun. Okay, now we're not as precise as people thought we were. All right, so why don't you try one for, well, do this one first. I may have done that one. Have we done that one? All right, let's just do this real quickly. All right, so I'm going to add by 2's, adding 2, so I have 2n. And when n is 1, I get 2. When n is 2, I get 4. When n is 3, I get 6. And how many of these numbers? -1. So you would say any term is 2n minus 1. Okay? Let me give you this one. $17. Don't say anything. Just raise your hand either if you think you got it or you notice something weird. Have you done
The
this?
quadratic is so much extra.
Good. Yeah, awesome. Do you know how to write it? Good. All right, so that helps my cause if you've heard this before. All right, so this is 3, this is 5, and this is 7, which again is really cute.
That means like the quadratic.
Look at this. You're right. That's awesome. I'm going to list perfect squares. Was Miss O'D your teacher?
No, this is the first thing she taught us.
Okay. So, but you've probably all seen it, okay?
I'll take credit.
Yeah.
The quadratic.
Like the quadratic.
Sarah, see,
Yes, linear, quadratic, cubic, exponential, they know. You name it, they know.
girls, what did I just list? Look. Because a lot of you are sitting there going, what is going on? I didn't know this when I was in pre-cal. So watch, okay? What did I just list? Perfect squares. If you never noticed, which I had not by your age, they skip. That's 3, 5, 7, 9, 11. Numbers are so bizarre. Like set numbers, I love this unit because you're just like, oh my gosh, this is so crazy. Like, why is this happening? Which again makes pi and e and some other numbers like the golden ratio even more puzzling because we're just like, what is going on with those? Okay? If you never noticed that, that's super cool, isn't it? And so you heard a smattering of girls saying quadratic. So do y'all see how if you take a perfect square, it's going to always go 3, 5, 7, 9? So these are some form of perfect squares. Anytime you add 3, 5, 7, 9, you drive yourself crazy trying to write that series that would make that happen. So I'm just going to go on and tell you. You're going to have n squared plus or minus something, okay? Right now, n squared is going 1, 4, 9, 16. How am I going to get these numbers? 2, 5, 10, 17. So you're going to have n squared plus 1. Okay? So if you see it skip by 3, 5, 7, 9, you have some form of n squared plus or minus something. It can be this far down the road. It can be 23, plus 3 is 26, plus 5 is 31, plus 7 is 38. And you could go, wait, that's 3, 5, 7. It's a quadratic, n squared. But you have to make it start at 23. Plus 22, will that work? Let's jump in the middle and find a sub 3. A sub 3 is going to be 9 plus 22, 31. It works, doesn't it? But I had to be told that, okay? I don't think I'd have gone crazy trying to find it. It's got a really cool pattern. So I've given you some inroads into things that look weird, that are not, this one's not arithmetic or geometric. The 2424 one wasn't arithmetic or geometric, okay? The last few that we've done were neither one. They had some certain components of both. All right, now, a couple more things. Okay, recursive is another thing that Bella's mentioned. You can do this, and many things are recursive. And I don't really, I guess I shouldn't say that as a teacher. Not really wild about recursive, and you're not going to be wild about them either because of this. If I tell you an explicit one, a sub n equals 3n minus 2, you could care less what I ask you. It's explicitly defined. You can find any term. Hopefully you won't list out the next 1,999 terms, okay? All right, recursive goes like this. Bella, where someone says, okay, the first term is 3. And so you could have done it with like something like this. I'm going to use their notation. They're all of a sudden using a K. You can see any of these. Okay, so we're supposed to, you'll see this on your homework, list the first 5 terms. Well, at least get partial credit. What's the first term? 3. Okay, don't miss that one. All right, how in the world are you going to find a sub 2?
So then a sub one, a sub k minus one for the, well, a sub k is 2, so a sub k minus 1 is a.
All right,
sub one.
so a sub, now you've got to really read your pattern, okay? Girls, all of a sudden, hang on just a minute, all of a sudden, you've got notation like that sitting in there and not just an N or a K. If you have this in there, what she's saying is it's actually calling a term up for you, not a number. Okay? So let's do what she said. When K is greater than 2, well, greater than or equal to 2. So now I'm on a sub 2. If this is a 2, what is this? A sub 1 plus 1. And what's a sub 1? 3 plus 1 is 4. Now what's a sub 3? Follow your pattern. I'm going to do it in green. A sub 3. If this is a 3, what is this? If this is a 3, this is a sub 2 plus 1. So what do you need now? A sub 2, which you better have gotten right? Because you see it's like a composite function, is 4 plus 1, which is 5. Hopefully you'll notice something and you can move a little faster. What do you think a sub 4 is? I think it's probably 6. And I've realized I'm going to take the term before it and add 1. Okay? So here's what's unfortunate. Granted, this one you could probably figure out. But you see you could run into a really bad situation in recursive. This one you could probably figure out. Okay? But just time out for a minute. Do you see what could happen with a sub 28? You would need which term? Yeah. And so if I say a sub 2000, wherever that went, you actually need the 1999th term.
Now, how would you find
So
that
then-
by the 1,900?
The 98th term. That's the problem with recursive. Okay? Many things are recursive, and sometimes you can't get away from it. But it's super embedded in Pascal's triangle and Fibonacci numbers, which are embedded in each other. All right, hang on just a second, Bella. Now, what you're going to want to do, which some of you, maybe what Bella's going to say, and I think what Rebecca noticed, and by the way, a sub 5 is 6 plus 1 is 7. You are welcome to then just continue the chain once you notice I'm adding 1 to the term before it. Okay? Now, let's try to write it as explicit. A sub n, we'll use a k. Can I change from recursive to explicit and make my life better? Okay? What are you adding by? 1. So you have a 1 in, and a 1 what? If I'm going to use k, I'm going to have a 1k. That would just start and go 1, 2, 3, 4. How do I make it go 3, 4, 5, 7? Okay. Now, can I jump in and find a sub 4? Is a sub 4 4 plus 2? Can I find a sub 999? If I can do this, I can. There are times that even I can't change it from recursive to explicit. But when I can, I want to. So you'll be asked to do that a little bit using our skills that we learned today. Bella, what were you going to say?
Oh, I was gonna say.
Sorry, I stole that. Yeah, and jump in, because she's you can tell she's already done this. So if there's something else you learned or like y'all threw in the arcane n squared thing, please jump in, okay? Okay, so the last thing we're going to do, which you already know, I think, is what does this mean? We really need those in sequences and series. It's called factorial. So if you don't know that, I didn't. I had not had a reason to know that, or else I just probably didn't quite catch it. That's 120. Girls, listen please. There's a factorial button on your calculator that if you don't understand what you're doing, don't even look at it right now. We'll learn it another day. If you don't know what you're doing and you're depending on your calculator, like we often say in my class, you've got to understand your math better. Many times you can type one from the ACT into your calculator and it goes into overflow. And you're like, great, thanks a lot. It means it's too big, I can't do it. These get big really fast and they're very real world. On your homework, if you see this, 83 factorial over 81 factorial. Those numbers are so gigantic that your calculator is going to try to find 83 factorial and is going to get stuck. I know that's 83, 82, don't get nervous, I'm not going to list them all, okay? Dot, 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 over 81, 80, what's going to happen? Cancel out to where your answer would be whatever 83 times 82 is. You'll see some of those just to practice with, okay? You might see this, n minus 1 factorial over n factorial. And if you want to find a sub n, a sub 1 would be 0 factorial over 1 factorial. A sub 2 would be 1 factorial over 2 factorial, and so on and so forth. Please look your answers up in the back of the book or on Slater so you know if you're doing it right. One more thing. Please pack up and be leaving. One more thing. 0 factorial is defined to be 1. It's not 0. 0 factorial is defined to be 1, and that makes all of that. It's an operator in this number system. Okay?
So 0 factorial
Is
is
1.
1 factorial?
Yes, there's the 9s. Yes. Bye, girls. I'll post your homework, and you'll have a memo quiz.